Question is from uncertainty. A ruler is used to measure dimensions of a cylinder. You know, a cylinder looks like this, a cylinder. The cylinder has, a cylinder has diameter. Drawing becomes difficult here. Discard. Hello. Hello.
Yes.
Yeah, sorry for that. I had a small meeting, that's why. Okay. So uh, we have a cylinder. And then here the diameter of the cylinder is given. Then height. So the diameter is 2 centimeter, height 20 centimeter, resolution 1/16 centimeter. So here we need to find the uncertainty. Uncertainty can be calculated using this. How we calculate the uncertainty? Uncertainty means error. How we are going to calculate the error? So a ruler is used to find the diameter, height, and resolution, and the error here, error in calculation is 1/16 centimeter. So we have to determine the uncertainty in measurement of volume. How to measure the uncertainty? So uncertainty is calculated using the equation uncertainty in volume. We know how to calculate the volume, which is pi over 4 d square h, which is pi over 4 d diameter 2 square times h is 20. Now the question is, you are using a ruler to find the diameter, the height. The error of the measurement is 1/16. How to find the uncertainty? So uncertainty is delta V over V. It is equal to square root of uncertainty in you calculate what are the factors affecting volume, diameter and height. So uncertainty in diameter square and then uncertainty in height square. So uncertainty in diameter square and uncertainty in height square. So delta V by V is equal to uncertainty in diameter is, see here in this equation you have two, here you have d square. So if you want to find d square uncertainty, 2 times delta d by d. So I will write 2 times delta d by d the whole square. Plus uncertainty in height is only 1. So 1 times delta h over h the whole square under the square root. So this will give you uncertainty in diameter square and uncertainty in height square. So when you calculate it, you can calculate the values. So square root of 2 times uncertainty or error in measuring diameter is the resolution 1 over 16 the whole square divided by d, the diameter is 2. So please take the whole square like this. So I will cancel this. Please listen again. So where I need to write? Shall I write here? Okay. Delta V by V equal to square root of 2 times 1 over 16 by diameter. How much is the diameter? 2, the whole square plus delta H by H. Delta H is 1 over 16 by H. H is height, which is 20, the whole square. Any doubt in this in calculating the volume ratio?
Doctor, why we multiply it by 2 in
Yeah,
diameter?
this is the equation. See, whenever if you have a parameter x raised to n, okay, you are finding delta x by x, the uncertainty n. It has to be, if you want to find it, then n times delta x by x. That's why I have used d square 2 times delta. You don't need to use pi by 4 because it is a constant. So error comes with the diameter and height. That's why 2 times delta d over d the whole square plus h raised to 1. So 1 times delta h over h the whole square. This is how we calculate the uncertainty. Clear?
Yes, doctor, clear.
So just substitute delta d is given. See, you have delta d and delta h are equal to 1 over 16. So delta d and delta h are given here 1 over 16. Just substitute 1 over 16 here, and then you will get the value. Delta d is 1 over 16 divided by d. Delta h is also 1 over 16. So you will get delta v by v. Okay, clear? So you will get delta v by v. So if you calculate it, you get the value as you can see here. Volume is this. The error delta v or EV. EV means delta v. Delta v by v equal to, how you calculate, square root of ED square plus EH square. So ED is 2 times UD by D. EH is 1 times UH by H. So 2 times UD by D the whole square plus UH by H the whole square. So from here we get the value, substitute the values, and we get the answer. So UD is how much? 1 over 16. D we have, UH we have, H we have. Hence we can calculate delta V by V. So delta V by V can be calculated using this equation. Anyone, can you calculate and give the value how much it is? So 2 and 2 get cancelled. So 1 over here 1 divided by 16. 1 over 16 square plus 1 over 16, correct, divided by 20. Anyone is calculating?
3.9, doctor.
Square root. If you take the square root of this.
Yes.
0.06.
0.06. Please confirm it. Another one? Can you please confirm it? 0.025.
Yes, doctor.
Yes, doctor, same answer.
Same answer. So we got delta V by V, delta V by V as 0.0625. From here, what is the error? delta V, volume error, is equal to 0.625 times volume. How to get volume? 0.0625 times pi over 4 d square times h. H is how much? H is 20. See, look at that. Then you will get the change in volume from here. Clear? So if you calculate this, you will get, see, V is the volume. You know how to get volume. Pi over 4, pi divided by 4 d square h. Okay.
3.9
3.931.
31.
Okay. Delta V. Okay. So this centimeter cube, what is the volume? Can you calculate? Anyone calculate only this volume? Pi over 4 d square volume. How much?
$62.8.
62.8. So then 62.8 is the real volume, but when you measure, you will have an error like this. This is the meaning of this question. Is that clear?
Yes, doctor.
Anything? So this is very simple. Whenever this d square comes, it is 2 times. If it is d cube, 3 times. If it is d raised to 4, 4 times. Error in diameter divided by diameter. If it is 1 time, h raised to 1, 1 times error in height divided by height. Like that, you have to calculate and multiply. But when you take the square, you have to take the whole square. 2 times ud by d the whole square plus uh by h the whole square. That is uncertainty in volume. Clear?
Yes, doctor.
This uncertainty, remember, EV means delta V by V. Error in V divided by V. If you want to calculate error in V, multiply by V. Okay. So tomorrow we have a lecture at 8 o'clock. Will they attend? More students attend tomorrow morning, or it will be the same?
Inshallah, more, doctor.
Today what happened? Any special day?
No, doctor, I don't think, honestly.
Okay. So tomorrow, okay. Now I have given a question here. Can you calculate it? Same thing. Measurement of uncertainty of G. You need to calculate G here. Uncertainty in G. Uncertainty in G means delta G. Okay. In order to calculate delta G, but delta G is inside the equation. You have to take it out because can you read the question 2 times before I start? Just read the question. Calculate uncertainty of G with the length L and period T with the L and T values. L is this, T is this. So what we need to do, we need to square left and right hand side. T square equal to 2 square 4 pi square times L over G. I squared it. Then G equal to 4 pi square times L over T square. This is the equation. Then how do you calculate delta G over G? Delta G over G equal to, sorry, keep and then, okay. So how do you calculate delta G over G? Equal to how? Square root of, yes, L raised to 1, right? So 1 times delta L over L, the whole square, plus T square. Even if it is divided, you can take it as 2. So 2 times delta T over T, the whole square. Can you calculate the value, how much you are getting? If you have delta L, what is delta L? See, delta L. And delta T, this is delta T. L, this is L. T, this is T. Can you substitute and tell me how much the value comes? Just calculate. I'm coming. Anyone got the answer?
I got 4.2 multiplied by 10 to the power minus 3.
4.2 multiplied by 10 to the power. Okay, I will write here. 4.2 times 10 to the power minus 3. Delta G. Hope that they all will have, or otherwise I will explain it again by G equal to square root of delta L is here 0.1 divided by L. L is 92.95. This whole square plus 2 times 0.004 divided by 1.936, the whole square. So you multiply them. So now just calculate the same value. Azam, all are getting the same value. Azam, Noor, Khalid, Halima, are you getting the same values?
Doctor, I get 4.26 multiplied 10 to minus 3.
This is the thing. Same value, right?
Yes.
So minus 3. So delta G over G, you have delta G over G is equal to 4.2 times 10 to the power minus 3. From here, you get delta G is equal to 4.2 times 10 to the power minus 3 times, you know, what is the value of G?
9.81.
9.81. So I put 981. 981 means why 981 is because 9.81 meter per second square. When you multiply it by 100, it becomes 981. So that's why 981. I'm going to put 981 here. So if you multiply by 981, because the value here you are getting delta G in centimeter per second square, correct? Because all of them you substituted in centimeter. That's why you are getting in centimeter square. That's why here you have to substitute in centimeter per second square. So what is the final value?
4.18.
4.18.
4.12
times 10 to the power.
No time, Doctor.
I
Just
just
4.18.
4.18. Okay. So the answer delta G is 4.18 means your answer will be 981. This is your G. You know 9.81, but I am expressing in centimeter, plus or minus 4.12. This will be the answer. G plus or minus. So when you measure with a simple pendulum experiment, the error can be plus or minus 4.12. This is the meaning. Clear? Anything to be explained, I will explain. I can explain it again. That's why I'm asking you if anything to be explained from my side, I can explain.
Doctor, the equation which say delta G over G equal the root of the under root, how we get it?
Because see, this is a constant, so you forget about this. L is a variable. L raised to 1, correct? Exponent is 1. So I multiply 1 times delta L over L, the whole square. The first one is length L. I finished. Plus, I'm here. First one is L. I finished L, correct? Second is T square. Even if it is divided by T square, you have to take the N here. N is 2 times delta T over T, the whole square. Not 2 square delta T by T square. It is 2 times delta T over T, the whole square. Now it is clear. Forget about the constants.
Clear, Doctor. Thank you.
Yeah, if you have a cube b square divided by d cube, how you will write? For example, E is equal to, you will write delta E over E equal to square root of 3 times delta A over A, the whole square, plus 2 times delta B over B, the whole square, plus 3 times delta D over D, the whole square. Look at that. How come you are writing? It's clear?
Yes, Doctor, clear.
This is how we calculate it. For all, it is clear?
Yes, Doctor.
Yes. So this is all about this. So I need to finish one more question. Shall we keep it for tomorrow? The last question of this tutorial or today?
Finish it today, Doctor.
Okay. So we have to design a go no go gauge for a component having 20. So the size fit size, the assembly is given as 20 H7 F8. Means the basic size is equal to 20. That is the meaning. H7 F8 is the fit or the connection. The H7 means IT7 for the whole, and F8 means this is IT7. IT8 for the shaft. This is the meaning. So as I taught you before, H is for the whole, F is for the shaft. IT8. Now here in the question, we need to design a go no go gauge. How to design for this assembly? You know where we are using go and no go gauge? Do you remember? Keep this and let me open the diagrams, please. Just a minute. I will open this diagram. The folder. Make 2118. No, make 3800. It is week 8. I think it is week 8 or week 9. Let me see, week 8. Quality control. Not week 8. Must be week 7. If it is in week 7. Week 7. Limits, fits and tolerance. Do you remember where we have studied? Limits, fits and tolerance. This we studied last time. So limits, fits and tolerance here. This limits, see here, these are the gauges, yeah? Go and not go gauges. So go and not go gauges means if you produced a rectangular block with say height 10, huh? 10 plus or minus 1. So if it is within that limit, it will go through this. If it is less, it will not go. That is the meaning. If it is more, then also it will not go. So 10 plus or minus 1 means what? It can be from 9 to 11. For if it is 8, it will not go. If it is 12, it will not go. So if it is 12, it will not go. Okay. So such kind of, so if it is between these two, you can check the upper and lower limits using not go gauge, not go and go gauge, a system like this. So this is basically the difference in the tolerance. If you see the tolerance like 10 plus or minus 1, maybe this one 9 and this one to 11. Using this, we can quickly check the material and we can say whether they are under control or not. This is called go and no go gauges. So here, as I told you about go and no go gauges, here, if I can copy this. No. Okay, it's clear, right? Go and no go gauges. You have seen it. Now we have to design a go and no go gauge here, as I explained before. Okay, we have to design a go and no go gauge. So as here, this is the design, and here this is the phase where you design it. One edge, so first two edges are there, go gauge, and second one not go gauge. This we have to design here. This is basically used in mass production industries where we produce a very large number of products. Go and no go gauge. So I is the deviation. I is calculated as 0.45 d raised to 1 over 3. So here the 20 millimeter falls in the diameter steps of 18 millimeter and 30 millimeter. The diameter, basic diameter is 20. Since it is given, it falls between the diameter steps of 18 and 30 millimeter. We can calculate the fundamental diameter. How to calculate the fundamental diameter? Equal to square root of steps 18 times 30. Very quickly, can you calculate and give me the value? Square root of 18 times 30.
23.23.
23.23. This is fundamental diameter. So we got the diameter D to be used all this in this equation as 23.23 millimeter. Next step is our deviation is given. Remember, these values are in microns. Microns. So the I value, see here, IT7. IT7 is for the hole because H7 is IT7 for the hole, which is 16I. IT8 for the, this is for the hole. This is for the shaft. So here, I we need to calculate. How do I get I is 0.45 times D raised to 1 over 3. Means 0.45 times D 23.23 raised to 1 over 3. How much is the value of I? Yes, here. Where is that? Yes, how much is this value, please? Raised to 1 divided by 3 times 0.45. How much? 1.284. This is all about I. We got the I value in microns. Microns. So in millimeter, I can say 0.001284 millimeter. In millimeter, I have 0.001284. That is I. If I get I, all are with me?
Yes.
Yeah. If I get I can calculate IT7 16I. Can you calculate the value and give me the exact number 16I? How much? The tolerance I am writing here, just listen. Tolerance for hole. Why hole? Because it is IT7, H7 equal to 16I, which is equal to how much?
0.0205.
Now, yes, correct. Tolerance for shaft. What is tolerance for shaft? 25I. Can you calculate 25I here? IT8 is 25I, correct? Shaft 25. 25 into this, how much?
0.0321.
So we calculated tolerance for the hole and tolerance for the shaft. Up to this, any doubt you may please ask. Up to this, any questions you may please ask.
No, doctor.
I can proceed.
Yes.
So this is a hole based system because it is written 20H7F8 based system H. Hole based system. In a hole based system, this is hole based system. You know that minimum hole is equal to the basic size. Minimum hole is equal to the basic size. So what is the minimum hole here? Minimum hole is basic size, which is 20. And maximum hole is equal to what? Maximum hole is minimum hole plus a tolerance. What is the tolerance for the hole? So 20 plus tolerance for the hole we calculated as 0.0205. That means 20.0205 millimeter is the maximum hole. So minimum hole is the basic size because it is a hole based system. Clear?
Doctor,
Yeah.
the basic size always come like minimum hole.
If it is a hole, if you go through the lecture, it is clearly given what are the combinations of hole based system and shaft based system. Okay. If it is if the system is based on hole, minimum hole will be always basic size.
But in this question, how we know it's a minimum hole?
See, that's the thing. If you see there, represented by H, and then this is the tolerance, then F8, such a system is termed as a minimum, such as a hole based system. So I will give here also whether it is hole based system or shaft based system. Okay.
Okay, doctor.
I will specify. So if it is a shaft based system, what you have to do? Maximum size of shaft, maximum shaft size is the basic size. Shaft based system. Maximum size of the shaft is basic size. Anyway, this is a hole based system. Minimum hole is basic size. Maximum hole is minimum hole plus tolerance. Clear? All of you clear or what?
Yes, doctor. Clear.
Clear. Clear. Now upper deviation. What is upper deviation? upper deviation. Do you remember upper deviation? If you minus from basic size, for example, basic size, what upper shaft, right? How much is the upper shaft here? Basic size or minimum hole or basic size. What is basic size? 20. So basic size minus maximum shaft. So this is called upper deviation. So if you want to calculate maximum size, maximum shaft, what you have to do is basic size you have minus upper deviation. So that's why this minus is shown here. It is less than the basic size. This minus indicates the value will be maximum shaft will be less than the basic size. So basic size is 20 minus upper deviation. Can you calculate upper deviation here? 5.5 times 20 D. What is D? D we calculated from here 23.23 raised to 0.41. So before that, let us calculate this. Anyone, can you calculate this? We have D 23.23. Anyone, can you calculate it?
minus 19.97.
Minus 19.97 means divided by 1000 is minus 0.0199, right? So here this will be equal to 20 minus this will be equal to 0.0199. So 20 minus 0.0199 is the final answer for calculating the maximum shaft. Maximum shaft is 20 minus this. Clear? Simple. You calculate upper deviation. Just substituting D here, you will get it in microns. This is in microns. Convert it into millimeter and then minus it from the basic size. Basic size is 20. 20 minus upper deviation. That means you are getting here 0.0199. That will be the maximum shaft size. Clear?
Yes, doctor, clear.
Yeah, this upper deviation is given in order to find the maximum shaft. Once you get maximum shaft, you can calculate minimum shaft. How to calculate minimum shaft? Once you have maximum shaft, how to calculate minimum? Minimum shaft is equal to
Minus tolerance.
maximum shaft minus tolerance. So maximum shaft is given here. Can you calculate how much is maximum shaft? 20 minus 0.0199, right?
Yes, 19.98.
19.98 minus tolerance. Tolerance for the shaft 0.0321. This will be equal to how much?
19.948.
19.948 millimeter. So did you understand this? How to calculate minimum hole, minimum shaft, maximum shaft?
Yes, doctor.
So I think all are sleeping, it seems. Huh?
Doctor, if the question ask to sketch the
sketch means like this, you can sketch it, but I didn't finish the question, almost 70% over. What I will do, I will explain, I will continue it tomorrow. Okay.
Okay, Doctor.
Okay, thank you very much for attending. Tomorrow, I hope that all will attend. Thank you. So tomorrow I will continue this. Please listen, tomorrow I'm going to continue this, okay?
Okay.
Thank you.